Here we go for our next lesson, solving exponentials. Your last lesson was short and sweet. So far, hopefully they've been manageable. This lesson plus the next one coming, you definitely want to make sure we've kicked it up a notch, so make sure you're paying attention. Don't be like Ariel and look away. Make sure you're dialed in for this lesson plus the next one. So we are going to use a variety of strategies to solve exponential equations. Our first example, we want to solve, which means you have to find x, and x is in the exponents. Okay, so we have to figure out a way at some point to get that x out of the exponents and down to being, a normal term. There's going to be two different ways that we're going to do this for this first example. The first way I'm going to show you is the grade 11 way. And then I'm going to show you how to do it the grade 12 way, which is going to help us when we get to the harder examples. First step, bring over that -7 becomes +7. So we have 2 to the x plus 4 equals 25 plus 7 is 32. In grade 11, you are taught to make both sides have the same base. So on the left, I have a base of 2. And on the right, you have to realize that 32 can be written as a power of 2 have a base of 2. Now this is depending on what your mental math skills are. Either you know that this is 2 to the 5 or it's just trial and error. And once you have the bases the same, right, to solve an equation, left side has to equal right side. So you have the base of 2 on both sides. This just boils down to you making the exponents be equal. So at this point, we can drop the bases and just work with the exponents. And from there, bring the 4 over, becomes negative. 5 minus 4, of course, is 1. How could you double check your answer? Well, you could go back up to the question, put 1 in for x, right? 1 plus 4 is 5. 2 to the power of 5 is 32. 32 minus 7, 25. It works. So there's definitely a question that you could have handled last year. I'm going to solve it using logarithms, which is going to help us solve much more difficult equations. So I'll rewrite it at this step. So regardless, your first step is still going to be move the -7 over. Let's say the number is really big, or you just don't want to go through the trial and error process of figuring out what 2 to the what exponent gives me 32. What if it was 33? 33 is not a power of 2. You'd be sitting there for a while on your calculator trying to figure out the exact decimal, like 2 to the power of some decimal has to be 33. So what we're going to do instead, and this is one of the laws from your last lesson, the one that's going to be used the most often, is the power law. And remember, the power law states that if you have a log, or take the logarithm, you can take an exponent and it moves out front and kind of becomes like a coefficient, or in this case, it'd be like a binomial term out front. So let's do that. Take the log of both sides. Remember, performing this operation, whatever you do to one side, you have to do to the other. You can't just take the log of one side. So I'm going to take the log of this and the log of that. Now the power law, remember, tells you that you can bring your exponent out front. So I'll make a little note here to get from there to there. We use the power law. Now divide both sides by log 2. And if you use your calculator right now, type in log 32 divided by log 2. You get 5. And you're basically right where we were on the other side when we did the grade 11 way and bring that 4 over, becomes negative 4. 5 minus 4 is 1. One B, solve. Again, you probably could handle this doing it the grade 11 way. But we're going to use logarithms. So step number 1, I'm going to take the log of both sides. So log 49 to the x minus 2 equals log of 343. Using the power law, your exponent can come down. And you can divide both sides now at this point by log 49. And using our calculator, log 343 divided by log 49 equals 1.5. So we have x minus 2 equals 1.5. Bring over the negative 2, becomes positive 2. 1.5 plus 2 is equal to a positive 3.5 or 7 over 2 if we're going to have fractions. Hopefully that's not too bad so far. We're kind of getting the hang of it. Exact same question. We still want to solve. We're going to slowly pick it up a little bit. Step number 1 for C, bring over the negative 10. So you have 2 to the x. 20 plus 10 is 30. Take the log of both sides. That way we can bring the x down using the power law. Divide both sides by log 2. And you're going to notice, so let's try this, log 30 divided by log 2. We do not get a nice number. So let's round to 2 decimal places. So hopefully you're looking at 4.9068 blah, blah, blah. If we go to 2 decimal places, 4.91. Approximately. Again, how could you check your answer? For a test, you got to show me your steps, but you could enter into your calculator 2 to the 4.91 minus 10. You should get roughly 20 because we rounded, right? D, same idea. Take the log of both sides. We don't have anything to bring over this time. So log 3 to the exponent 4x plus 1 equals the log of 276. Using the power law, the 4x plus 1 comes out front. Log 3, log 276, divide both sides by log 3. Using our calculators, log 276 divided by log 3. We'll go to 2 decimal places here. So we'll say 4x plus 1 equals, you should be looking at 5.1159, so 5.12 if we round. Bring over the positive 1 becomes negative 1, so 4x equals 4.12, divide both sides by 4. 4.12 divided by 4, we get 1.03 approximately. Now, if you want to do that all in one step, so let's say you don't want to round, which I'm okay if you want to round. If you don't, I'm going to challenge you, I guess, to get a more exact answer. And the exact answer would be, since log 276 divided by log 3 was not a nice number, you would go through the algebraic steps. So you're at log 276 divided by log 3. Okay. Then you would bring over the 1, becomes minus 1. and then you would divide the whole thing by 4. So depending on your calculator skills, you could do that whole thing just as is. So log 276 divided by log 3 minus 1, and then divide by 4, and you get 1.03 again. So we were pretty close with our approximation. While I think of it, a common question that comes up: does my calculator have to be in degree mode or radian mode working in logarithms? And the answer is it does not matter. As long as you're not doing like logarithms of pi's, you're completely fine. So the degrees or radians, whatever mode your calculator happens to be in for that, it only matters when you do trig or have pi involved, which we won't. So you don't have to worry about that. E, still solving. This is a very good question. So I'm going to put a star here beside this. This is really our first challenge we've encountered. And the reason why this is a challenge is because we actually have exponents on both sides, and we have an x in the exponent on both sides. Same process, it's just going to look a little bit more complicated. So I know that I have to solve for x, and x is an exponent. I got to get it out to be like a constant term, a normal size term, not just an exponent. So I got to use the power law. How do I do that? Take the log of both sides. So log of 2 to the x plus 1, log of 3 to the 3x minus 5 using the power law. Those exponents could come out front. Just like that. Now so far we've only had x's on one side, and so we would just divide by log whatever and do some algebra. I got x's on both sides, so I can't just divide by log 2 or divide by log 3 because I got x's on both sides. So what you want to do here is you want to distribute. Okay, log 2 is just a number. Log 3 is just a number. It's not a nice number, but it's just a number. And when you have a coefficient or a number outside of brackets, what do? Distribute. So we're going to distribute this into both terms inside the brackets. So that leaves me with x log 2, right? Log 2 times x, then log 2 times 1, which is just log 2. Same thing on this side, distribute that in. So log 3 times 3x gives us 3x log 3, and then negative 5 log, oops, pen drag there, let's erase that. So minus 5 log 3. Then from there, we want to have all of our x terms on the same side and all of our non-x terms on the same side. So x log 2 I'm going to keep there, and I'm going to bring this 3x log 3 term across, and it's become minus. So minus 3x log 3 equals, and then I've got a negative 5 log 3, and then I'm going to bring that log 2 across, and it's going to become minus log 2. I got x's on both sides. I got x's on one side now. It's part of the battle taken care of. But how do I isolate the x now? You could, I shouldn't say this, but I'm going to. You could find what log 2 and log 3 are and round. I don't like that. I don't like when we round within the question. I only like when we round at the very end or close to the end. A better strategy is to common factor out the x out of the two terms on the left. So if I common factor an x, that leaves me with log 2 minus 3 log 3. equals all of that junk. Negative 5 log 3 minus log 2. Now I can divide both sides by what's attached to the x. So we're almost there. So if I divide both sides by log 2 minus 3 log 3, those are gone, just leaves me with x. And divide that by log 2 minus 3 log 3. And you can do this basically all in one step in your calculator. If you put brackets around the numerator and brackets like that around the denominator, you can enter it just like that. Bracket negative 5 log 3 minus log 2, close bracket, divided by bracket log 2 minus 3 log 3, close bracket. And let's round to 2 decimal places, we'll say. If you did it, hopefully you got x equals 2.38 when you round. If you did, virtual high five. How could you check your answer? Take 2.38, put it back into the question. Do 2 to the 2.38 plus 1, hit equals, write that number down, and then do 3 to the 3 times 2.38 minus 5, hit equals, write that number down. They should be more or less the same. They might not be identical because we rounded right at the end. So again, make sure, I like that question. We start it. Make sure you have a good idea of how to do that. Example 2, not necessarily solving. It says determine x. And even though it's found in this lesson, it's going to pop up throughout your test and your review, so you're going to have to recall some previous knowledge. You could have solved A without knowing anything about solving. That's just your change of base, log of the big number divided by log of the small number. So x equals log 35 divided by log 7. That's just your change of base formula, round to 2 decimal places, 1.83. Another way to do this, rewrite that in exponential form. So I have a base, right? That's my base of 7. The answer to any logarithm is an exponent, so 7 to the x. This right here is the solution, 35. And we could take the log of both sides. Log 7 to the x equals log 35. Power law says the x can come out front. Divide both sides by log 7. And we get x equals log 35 divided by log 7, which is just 1.83 again. In a roundabout way, we just proved the change of base formula. We proved that it works. For B, it doesn't matter how you do it. You can rewrite it as an exponential, change of base formula, it doesn't matter. I'll do change of base. Either way, log of 100 divided by log of 5, 2 decimal places, approximately 2.86. So we went from a starred question, back it off, get a little bit easy. Now we're going to be heading back to a challenging question. Okay, solve for x. How do a and b look different than what we've done so far? Well, there's now like more than 2 terms, and there's multiple terms that have an x in the exponent. Now, a common mistake, and I like where your head's at. A common mistake here is to have the idea of taking the log of both sides. But when you take the log of both sides, a common mistake for students, make sure you're paying attention to this because this is a common mistake. Students will do this. Log, log, log. Again, I like where your head is at. Unfortunately, that's not mathematically correct. you've taken the log of each individual term as opposed to taking the log of both sides. So really what this would be mathematically, you can't have that one there. And you'd have to have the log of like this and this in brackets. And while that's a step, it would be hard at this point to get the x's out because you have the 8x to the, or 8 to the x plus 1 plus 8 to the x all in the same bracket. That's not how the power law works. If they were multiplied, we could use the product law and split it up that way, but unfortunately it doesn't work that way. And you can't distribute a log in. Like you can take the log of a number, so you could take log 3 and distribute that in like we did in a previous example, but you can't distribute just a log. Another common mistake. Just like you can't distribute a sine or a tan. So now that we've gone over what not to do, and hopefully nobody makes that mistake. I mean, if history is any indicator, probably at least one of you will, but fingers crossed, we paid attention, we're not going to make that mistake. For a question like this, which I'm going to star, you have to realize that you have the same base. I'll even look at B as well. You have the same base in both those terms. If you have the same base, you can common factor. It's going to look weird, or it's going to be like a little bit trickier to wrap your mind around, but you can common factor. And what you can common factor out is 8 to the x for A. I'm going to come back to the first term. We're going to go to the second term. If I common factor out 8 to the x, out of 8 to the x, remember factoring is just dividing. 8 to the x divided by 8 to the x, that's just 1. Now, here is where things get a little bit tricky. 8 to the x plus 1, and you common factor out 8 to the x. A couple different ways to think about this. You are dividing. And going back to our exponent rules, when you divide like bases, what do you do to the exponents? You subtract. So if I have this divided by 8 to the x, and I subtract, right? X minus x, x's are gone, 1 minus 0, just left with 1. I'm left with 8 to the 1. The other way to think about that is think about it in reverse. So knowing that you have to end up with 8 to the x plus 1. When you multiply and distribute, you'd be asking yourself, well, I know whenever I multiply like bases, I add the exponents. So if I had 8 to the x, what would I have to multiply that to get x plus 1? 8 to the 1, because you add the exponents. Hopefully that makes sense, but really all you're doing is dividing both terms when you common factor by 8 to the x. How does that help us? Well, that's just a number. What is 8 to the 1? 8. What's 8 plus 1? 9. So I'm left with something like this. Yes, it looks weird to have the constant term in the back. You can write it out front as a coefficient if you want, but all you gotta do to get rid of it, divide both sides by 9. 576 divided by 9 is 64. How you do this is up to you. I would fully be okay with someone telling me the answer is 2. Hopefully you know that 8 squared is 64. If not, skipping a step here, you would take the log of both sides, then use the power law, divide both sides by log 8. Log 64 divided by log 8 is 2. You can skip down to here if you want. That's okay. B, same idea. We're going to common factor. And if you like to think of it as dividing, perfect. So common factor out 2 to the x. What does that leave me with? Well, when I subtract the exponents, x minus x, they're gone. I'm just left with 2 to the 2. Negative 2 to the x divided by 2 to the x. Anything divided by itself is just 1. So minus 1 equals 24. 2 squared minus 1, that's 3. So 2 to the x, 3 equals 24. Divide both sides by 3. 24 divided by 3 is 8. Again, you might know the answer to this. It's 3. In case you don't, x log 2 log 8, divide both sides by log 2. Log 8 divided by log 2 is 3. And again, you can skip from there to there. No problem. How do we feel about that? Hopefully not too bad. If you do feel bad about that, maybe take a deep breath. Close your eyes. Envision yourself as a math genius again before we get to the next one. Because if you don't like that, you're not going to like the next one. Our last example. Find the point of intersection between the graphs. And you can't do this graphically. You have to do this algebraically. So, remember, when you're looking for the point of intersection, going all the way back to grade 10, you're looking for an x and a y coordinate. I got y equals, set them equal to each other would be a good first step, a good start. So 92 to the x has to equal 433 to the x. Now, if you want to, this doesn't work for every question, but if you want to, you could realize that the coefficients 2 and 4 are related. And you could actually get rid of one of them by dividing both sides by 2. So then that would leave us 92 to the x. 4 divided by 2 is 2. Leaves us with that. Makes it a bit smaller. I now got to take the log of both sides to get those x's down, right? So log 92 to the x equals log. And remember, you're taking the log of the whole thing, the whole argument. So the log of 233 to the x. On the left side, this is easy, power law, x log 92. On the right side, you got to realize something. You're multiplying, right? 2 times 33 to the x. Definitely don't do 2 times 33 is 66. Definitely don't do that. That'd be very, very bad. But we're going to recall another law. When you multiply, that is the product law. And the product law states, remember, that when you multiply, you can change them to just add. So this really is log 2 plus log 33 to the x. And we did power law to get from that step to that step. Okay, so x log 92 equals log 2 using the power law plus x log 33. And we've done a question like this already. Bring your x terms to the same side. So x log 92 minus x log 33 equals log 2. I'm going to continue up here. Common factor out the x. Log 92 minus log 33 equals log 2. Divide both sides by all that. X equals whatever you get when you do log 2 divided by log 92 minus log 33. And on the question I said go to 3 decimal places. So let's go to 3 decimal places. Log 2 divided by, and if you want to do it in one step, enter the denominator in brackets. You should get x equals, if we round, 0.676. Now we're not done yet because all you found is x. We want to find the POI. We need an x coordinate and a y coordinate. Pick one of the equations. It does not matter. If you've done your work right, you'll get the same answer. So let's try y equals 2 and then 92 to the x. If I put x in there, 0.676, and just use my calculator, 3 decimal places, you should get 42.527. To answer our question, therefore the POI is x comes first, then y. How could you double check your answer? Put in 0.676 into the other equation, into the one that's y equals 433 to the x. You should get 42.527, just like we did for this one. If not, you've made a mistake somewhere. Going with a few different themes here, this is definitely a question I'm going to star that you might want to highlight in your notes. But definitely doable. That's it for your first solving lesson. The next lesson, as I mentioned in the beginning, is also going to be one you want to pay attention to. There's some seat work. Make sure you double check D2L for the updated questions. That is it. Goodbye for now. Thanks for listening. Happy mathing.